Welcome to Zaption Tour 9-3, solving quadratic equations. So I'm going to ask you a question to start this off with. What does it mean to solve a quadratic equation? So when you see this word here, what does it mean to solve a quadratic equation? As an example, if I gave you 5x squared minus 25x equals 0 and I said solve it, what would you do? Most people would answer get x by itself or solve for x or something like that. So hopefully that's what you did, or that's what you said, and that's what this lesson is going to be about. Okay, here's box number 1. There are 3 ways to solve a quadratic equation that are in the form of ax squared plus bx plus c. You can solve them by graphing. Okay? You can solve them by factoring. Or you can solve them by using the quadratic equation. Okay, so today we're going to focus on these areas like graphing and factoring, and then we'll spend a whole nother day working on the quadratic equation all by itself. So let's take a look at box number 2. It says solve the quadratic equation by graphing. I have already graphed for you 3 quadratic equations. There's this one, x squared minus 1. There's number 2, which just says y equals x squared. And then there's number 3, which says y equals x squared plus 1. So my question is, how do I solve the equation just by graphing? What do I do? What do I look for? So hopefully you put together that the way that we solve a quadratic by graphing is we look for where the graph intersects the x-axis. So in this case, there would be 2 solutions. X would be -1 or x would be 1. So there would be 2 solutions. So it is possible for a quadratic equation to have 2 solutions. Let's take a look at example number 2. How do I solve by graphing y equals x squared? Well, I look at the place where only the graph intersects the x-axis. There's only one spot, and that happens to be where x is equal to 0. So it is possible for a quadratic equation to only have 1 solution. So this one only has 1 solution, whereas the first graph had 2 solutions. And it's even possible for a quadratic equation to have no solutions, such as this one over here, because the graph never ever touches the x-axis whatsoever, so there is what we call no real number solution. The reason we say there's no real number solution is because the x-axis is acting like the real number line, and since the quadratic never touches the x-axis, then there is no real solution. Okay, in box number 3, I'm going to show you how to use Desmos to graph and solve quadratic equations. So you're going to have to switch back and forth from the lesson to Desmos, so just follow along with me. So let's graph number 1, y equals x squared, or x squared minus 16 equals 0. So if we're going to graph something in Desmos, we got to put it into y equals form. So I would say y equals x squared minus 16. So then I would see on the graph that there are 2 places here that my graph actually touches the x-axis. The x coordinates are -4 and +4. That's what I'm interested in. I'm interested in where the graph actually crosses the x-axis. So in Desmos, you can just sort of put your cursor on the curve next to the x-axis and it will tell you the x-intercepts for yourself. So therefore, we go back to our lesson here. So this one, the solutions would have to be x equals plus or minus 4, and you are allowed to leave it just like that. Okay? Let's do the second one. 3x squared plus 6 equals 0. If I go back to Desmos, I'll turn this one off, and I solved 3x squared plus 6 and set it equal to y. And you'll notice here that the graph never touches the x-axis, so therefore there would have to be no solution to that particular quadratic. So I'd go back over to my notes and I'd say this one has no real number solution. Hopefully that makes sense to you guys. Okay? And then number 3, x squared minus 25 equals -25. Well, if I just add 25 to both sides of this, I would see I would get that x squared is equal to 0. So this is just the equation y equals x squared. So we know what that one looks like. That's just a regular old parent function. So when I graph this one, y equals x squared, and I bring my cursor over and I touch, obviously the point is 0, 0. So therefore the answer to this one, the only thing would have to be y would equal, x would have to equal 0. X equals 0. Box number 4 is all about solving using the quadratic square roots or factoring. So solve the quadratic by using square roots or factoring. So take a look at this quadratic. I have 3x squared minus 75 equals 0. So one thing that I could do is I could say that 3x squared is equal to 75. And then I could divide both sides by 3. And I could see that x squared would have to be worth 25. So x would have to be plus or minus the square root of 25. So x is either positive 5 or it's equal to negative 5. That's one way that we could do it. I'm just solving using square roots. Another way we could do it, this one over here, we could factor out a 2 first, but then I would miss the negative sign. So the proper way to do it is to do what I just did. So 2x squared is equal to 8, divide by both sides by 2. So we would get that x squared would have to be equal to 4. So x would be plus or minus the square root of 4. So that would give me positive 2 or negative 2. So sometimes we use square roots to help us solve quadratics. Okay, box number 5 is a U-try. Go ahead and solve by using square roots and factoring. Hopefully you got the right answer, but if not, you should realize that move the 45 over, divide by 5. You can see that x squared is worth 9, and then take the square root of both sides, being careful to use the positive or the negative when taking the square root. And my two solutions would either be 3 or negative 3. And box number 6 is all about showing you sometimes quadratic equations have no real number solutions. Let me give you an example. So if I was trying to solve x squared plus 7 equals 0, I would see that x squared is worth negative 7, and then I would take a square root of negative 7. Well, we all realize that we cannot take the square root of a negative number in the real number system. So whenever this happens, your answer would be there are no real number solutions, which means that this quadratic would never ever touch the x-axis. Same thing over here. If I do 3x squared is worth negative 12, and I divide both sides by 3, I get x squared is worth negative 4. And in my next move, I would try and take a square root of a negative number, which would tell me that there are no real number solutions, meaning that this quadratic will never touch the x-axis.